Children, since we have crossed the around 2 months longer lockdown stage and has been given liberty to bring our lives back to track with first page of Unlock. Again, I will say that don't unlock your spirit to fly frivolous, but must master it with your maturity. So again, why I missed the chance to give you a DIY? This time I will tell you that whenever you are visiting a supermarket, and that's too in needs, never hold the basket and trolleys, which are the most possible places for this vampire germs, I will say. Instead, use tissue paper to carry. So here I am keeping my promise to bring the final topic of the chapter, which is the separation method, where we have to separate the different components of the air, which is the mixture of atmospheric gases. So this is really a lengthier process, a more challenging process, and let's see whether I becomes, because I am also a little much doubtful, I become successful in giving you the right knowledge or not, but I have kept my fingers crossed. So with this determination in my mind that where there is will, there is way, I commence the topic, and I hope that I will be successful. So air is a homogeneous mixture, everybody knows that, and it is a mixture of atmospheric gases. These atmospheric gases are what that you also know, so I am not giving much time on all those known things which you are learning since your childhood. So it is a mixture of different gases, and these gases individually also in a mixture form we are inhaling it for the survival of our life, but different life processes and different activities in our life demands these gases alone, individually. So from where we will bring it, naturally we will separate it from the air, because in the air they are already available in the abundance. So why to go for any manufacturing details and in a chemical method to prepare them? Why not we just use so just by going through the right applications and choosing the right separation method, I hope that we can reach to the conclusion, and we can be successful in separating the components of the air. So what are the steps which are involved in this process? First of all, air as a whole, which is a mixture of different gases, is taken and it is sent in the compressing and cooling chamber. I am telling you with the help of flow chart, and then I will give you the elaborate information also, don't worry. And after that, when the air gets liquefied, then this liquefied air is sent to the fractional distillation tar, and where the gases get separated at the different heights. So these are the gases which are getting liquefied at extremely low temperature. Here I want to give you one information, that when the temperature goes beyond minus 100 degrees Celsius, then this temperature is called cryogenic temperature. So just by using some simple type of coolants and all, like we use the frozen water or ammonia gas, etc., which are chlorofluorocarbon. This is just a matter to say which is given in NCERT book, but it is far from reality, I will say, because the cryogenic engines or cryogenic setup is required to carry out the process successfully, and then the separation can be done, because this much low temperature can't be achieved by the normal kind of coolants. So children, here I am again ready with my most handy teaching tool, and that is your NCERT book, because I truly trust in this book, which is highly scientific. You can see the diagram. This diagram shows the separation of the components of air. You can see it is a bigger diagram where the several steps are looking one by one lined up. First is a filter. You can see it very clearly. I have focused on it. Filter is what type of filter? That filter allows the air to get filtered. But it is not the normal kind of filter, but it is a very special type of filter, which is actually the molecular sieve. Molecular sieve is so fine in its pores that it can allow the particles to enter inside it, which are even smaller than 1 angstrom. 1 angstrom is actually equal to 10 to the power minus 10 meter. We can understand its tinier size. So suspended particulate matter, because in air there are lots of dust particles also, get separated here because they are much bigger. Then water vapor whose size, water molecule has size as bigger as 2.75 angstrom gets separated here. Now air, after the separation of these two components, enters in the expansion jet. In the expansion jet, there are pistons attached to its wall, so air is continuously compressed and expanded. So the piston applies pressure over the air, and in this process of the continuous compression and expansion, air becomes exhausted and warm, hot even. Why? Because the air particles get collided to each other, and this collision, the heat energy is gained, and the heat energy makes the air finally warm. Then this warm air and the air gets highly exhausted. What is the benefit of making the air exhausted in the expansion jacket will become very clear soon. So this hot air is transferred in a cooling chamber. This cooling chamber actually does plays the magical role, I will say, in the liquefaction of air, because the first air is liquefied, and then liquefied air is subjected towards the fractionating column, where it is separated by the fractional distillation process. So in this is actually the cryogenic setup that I was telling you. Here also it is just given that in the NCERT that freezing cold water is going inside it, but that's not a cup of tea of any freezing water, that it will liquefy your air, hot air. So hot air is cooled as low as minus 200 degrees Celsius. You can understand the temperature is looking impossible. But that temperature is achieved by the cryogenic engines. So this extremely at minus 200 degrees Celsius air now here, which is the mixture of carbon dioxide, argon, oxygen and nitrogen, because only 3-4 components of the air are now left behind, gets liquefied suddenly at minus 200 degrees Celsius, because it was already exhausted and it has been given an extremely chilled setup where it gets liquefied, and then this liquefied air, so half of the battle is won here. Now this liquefied air is sent to a separator jacket. What is the role of this separator jacket in this process? Separator jacket again has a molecular sieve. You can see by the dotted line it has been shown, the separator jet has a molecular sieve whose size is even smaller than 1 angstrom, because what is done here is the separation of carbon dioxide, because the carbon dioxide is sublimating substance which doesn't have any liquid state. So during the process of liquefaction, other gases gets liquefied and carbon dioxide gets solidified. So now the carbon dioxide, which has converted into its solid particles, and the size of the carbon dioxide is 10 to the power minus 12 angstrom, means which is 10 to the power minus 12 meter is equal to 1 picometer, and the size of your carbon dioxide is 1 picometer, means it is smaller than even an angstrom. So this molecular size sieve has the pores even finer than an angstrom, which can easily separate the carbon dioxide. So the carbon dioxide particles, which is also called dry ice, children. Dry ice you might have heard. I will tell you in this class only that where they are used actually in our day-to-day life. They are very useful substance. So the liquid air, which is free from the solid particles of the carbon dioxide, now going inside the liquid air is going inside the expansion jet, where the air is expanded, means the compression gets released from the air and the air is expanded in this expansion jet, and after the expansion of the air it is transferred into the fractionating column. Here we are coming with our original topic, which is the application of fractional distillation after so long. So in this fractionating column, first of all, nitrogen is separated and argon is, after that argon is separated, because the nitrogen gas is separated at the lowest temperature. So nitrogen is converted into its gaseous state in the your expansion jet, and then it is separated at the uppermost part of the fractionating column. And then after the separation of the nitrogen gas in the topmost column of the fractional distillation process, it is condensed back to store in the cylinder. Every time gaseous state is separated and it is stored in the cylinder in the liquid state by the compression. Then argon is separated. Argon has your boiling point at minus 86 degrees Celsius, and the nitrogen has the boiling point at minus 196 degrees Celsius. So first of all nitrogen and then argon. After that, the remaining air is left only with the oxygen gas, and that oxygen gas is transferred into the another you can see rounded container, where it is stored in the form of liquid oxygen. So this was the whole process I tried to explain you. I hope that I must not have dissatisfied you. So this is the way the fractional distillation of the air is done, and the different components of the air are separated. So after covering this super scientific process, I am trying to take its value based part, which is the application level of the science, because we have separated the different gases of the air to use in our everyday life. So first of all, we start with the carbon dioxide. Carbon dioxide, which is also commonly known as dry ice, is used where? It is used as a coolant, because it is converted into dry ice bricks, and these dry ice bricks are kept inside the compressor of your coolants like refrigerator and air conditioners, etc. Their compressor keep this dry ice. So this is a coolant. Apart from that, during the stage performances also, you might have seen that when the dance performance etc. is going on, the smoky cloudy atmosphere is created. That is also done with the help of dry ice. Bricks are kept everywhere on the stage, and it sublimates in the air, and due to the sublimation process, a very cloudy appearance is formed, and which looks very nice, and you can say very catchy. Now the next one is your oxygen gas. Oxygen gas is liquefied and it is stored in a cylinder, and it is not a very new thing that in this corona time, what is the role of oxygen gas? Everybody knows that it is given to the lung to inflate, and because when person starts dying, the first thing is give the life backup, and that is through the ventilator oxygen is supplied. Now nitrogen actually is the gas which is very inactive gas. You might have heard that this is the inactive part of air. So is its inactiveness not a blessing? Yes, it is a blessing, because the inactiveness of the nitrogen helps in storage of the blood, eyes, different organs in their banks, because it does not allow any type of reactivity in these organs, and that's how the blood doesn't get spoiled. Eye also remains in intact position, and then your organs, which are the essential organs, also remain safe. Now coming to the argon is used in the creating illumination in the vapor light, making the plasma appliances. Might have heard plasma TV and all. So plasma is you can say third generation electrical appliances, which are expensive but consume very less electricity. This is the argon gas, which is an inert gas, and that is excited to give the illumination. So this will be a topic of the plasma state, which I will tell you sometimes when I am in free time. So this was all about the uses of the different gases which has been separated by the process of fractional distillation. So boys, now I say goodbye to this chapter. Okay, goodbye.